So this is your check for understanding number 5. Now I do want to go back over here, and I am going to show you, because that last problem, I realized I had a different question on there. So if you were on the last page and you missed that, here is what I put on those, just so you can see them all by hand. You calculate the R, and then interpolation and extrapolation, just so those are on there. Okay, so here we go. This is your check for understanding of your linear regressions. The best fitting line to a data set is given by y equals this. So they're giving us the line of best fit. If the mean for y is y bar equals 8.75, what is the mean for x? So here, we're going to look at this, and here we go. Y equals 5.25x minus 2.84. What I know is y bar. If you know y bar, you can plug that in over here, and we can say that is 8.75. And then I'm going to say equals 5.25. The x value, if this is y bar, this would be x bar. I'm going to put that in parentheses, minus 2.84. I'm going to solve that for x bar, because if you're finding the y bar, x bar would be this value here, because y bar and x bar go together. So if I do a little math and solve this, I get 8.75. I would add 2.84 to both sides, and that would give me 11.59 equals 5.25 times x bar. I would divide both sides by 5.25, and I got 2.2076 equals x bar. So I would simply say 3 sig figs, 2.2, the 7 would round the 0 up to 1, and that would be what my x bar would equal. Okay, 23. The scores of 10 students are collected from their English and their history exams are shown. A student sits the English exam and scores 62%. Unfortunately, the student was absent on the day of the history exam. Okay, so here we go. Sorry. Unfortunately, the student was absent on the day of the history exam. Use the line of best fit to predict what the student might have scored on the history exam to the nearest percent. Is this prediction valid? So here's what we're going to do. We're going to go here. We're going to go to Stat, Edit, and we are going to go up and clear all this out. It would help if I hit clear when I did that, right? Let's put this in. So I'm going to call this L1 and this L2. And I'm going to put all this data in: 54, 59, 50, 75, 82, 67, 71, 73, 44, and 60. 65, 71, 63, 78, 87, 66, 70, 76, 58, and 65. Double check. I believe I got them all right. So would they want us to do a line of best fit? So let's do 4. Go back up here and store it. Alpha y equals y bar. Store it in the one variable. So there it is. So I'm going to come here. I'm going to write down what I got. I got y equals 0. I'm going to do 3 sig figs as I write this. So it'll be 6, 3. The 9 is going to round the 5 to a 6. X plus 29.5. Okay, so there's my 3 sig figs. So the question is, what did he make? A student sits the English exam, I think it's supposed to be out, and he scores 62%. Oh no, I guess that is really weird wording. So he sits and takes the English exam and he gets a 62. So he's right inside here, and he gets a 62. And the question is, what is this down here? So I'm just going to substitute it in. Are y'all good with that? So I'm going to say y equals 0.636. I'm going to plug in 62 for his grade there, because he got a 62 on the English, plus 29.5. Okay, I'm going to plug that in. Oh, did it give me, make sure I didn't miss a decimal, the nearest percent. Okay, so I know it says to the nearest percent. So I think when I solve it, I need to double check it that way. So 0.636 times 62 plus 29.5 So I get 68.932. Use a line of best fit to predict what the student might have scored on the history exam there's what I was looking for, to the nearest percent. Meaning they don't want decimals. So the 9 is going to round the 8 up. So a predicted score would be a 69% predicted history score. Now, the last question is this prediction valid? Can I use this prediction? Is it an acceptable prediction? I'm going to put 69 right here. And the answer is yes. And the answer, why is it? Because it's within the range of the values that I'm using. It would be an example of interpolation. Okay, so I'm going to say yes, it is a valid prediction. I'm going to do a little shorthand there because it's interpolation with the given data. I could just say it's within the X range, however you want to say it there. Okay, let's look at this next one. Consider the following bivariate data. Excuse me. Use the regression line to estimate the value of y when x is 50. Comment on the reliability of this estimate. Okay, so we're going to plug this data in, and we're going to get the y value. Now, for time, because I don't want to take the time to plug all that in, it's different data than what's up there. I would do L1 and I would do L2. When I did it in my calculator, I got y equals negative 0.864x plus 73.8. I don't want to take the time to put that in for the video. All right, so they want to know, estimate the value of y when x is 50. So y equals negative 0.864. We're going to plug in that 50 for x plus 73.8. When I solved that, I got y equals 30.6. It did say, actually, it did not tell us what to estimate it to. So I would probably leave it at 30.6. Most times you would estimate the value of y. Since they're giving all of these as whole numbers, a lot of times you might say, oh, it's actually 31. You don't even know what the data is representing though, so I think I would just stick with 30.6 unless it says to, round it up. Then the only other thing it says, is it a reliability of this? Well, what I noticed when I put that in my calculator and I went to the R value, I noticed that R is negative 0.262. And I'm going to let you look at that for a second. Is that data reliable? Hopefully you're thinking, well, no, not really. Not reliable. Because you're like, but wait, 50 is inside here, Mrs. Dean. That seems normal. Yeah, that does. Why is it weak? Oh, I just said it. Why is it not reliable? It's because it is a weak correlation. It doesn't matter that it's a negative correlation. Yes, it's a weak negative correlation. But the negative and positive doesn't matter. What matters is that it is a weak correlation. That's what matters. So it's not reliable. All right. Moving on. Where am I at? I believe I am to Spearman. So I'm going to go ahead and stop this video and move on. I'll make another one for this one. Oops. If I can get that back.